In this video, we're going to talk about the two branches of statistics, descriptive statistics and inferential statistics. So when you think of the word descriptive, it probably makes you think of describing, right? When you're looking at data and describing it. An example of descriptive statistics in the US is the census, right? This is where data is collected from every subject in the population, right? Every household has to fill out the census to state facts like race and age and income. And it's a big deal, right? It impacts things like public funding, which goes to schools and hospitals, and things like how many seats in the House of Representatives each state gets. But it's not always practical to use the entire population of the US for a study, right? Not every study can use 330 million people like the US Census does. So usually when we're collecting data, it's going to be from some type of smaller population, which is what we call a sample. Right? So why is that sampling necessary? Right? It's not really practical to use the entire population for your study. It can be expensive or time consuming because of the size of your sample, right? Even the real US Census is only done every 10 years because it's so time consuming. The other thing we want to consider when sampling is avoiding bias. So take this skateboarding example. Right? Let's pretend you're conducting a survey about whether or not skateboarding should be allowed in public areas. Let's think about who our sample should be, right? Do we want to ask the senior citizens at the community center who, might have a bias and not really be into skateboarding because they didn't grow up with it? Do we want to only ask parents who, again, might be biased depending on if their child is a skateboarder or not? Do we want to ask just skateboarders who obviously will end up overestimating the amount of people that actually do want skateboarding to be allowed? Or should we choose the better random option D, right? Which is all residents of the community who pay taxes. That will include some senior citizens, some parents, also some adult skateboarders. Picking that random sample is going to avoid bias, right? And we want to make sure that we're not over or underestimating that data. All right, so descriptive statistics is using data to provide descriptions, right? And it's usually going to be presented in some type of meaningful way. So this could be like numerical, could be a table, could be a pie chart or a histogram, right? And notice here that it's not the typical variables and values that you're used to seeing in math, right? We're used to seeing X and Y on our graphs, but now our variables are going to be characteristics. Like it could be hair color or country, race, number of siblings. Likewise, the values that those variables will assume are not going to necessarily always be numbers, right? So if we're talking about the variable of hair color, right? Now the values are going to be like brown and blonde and black and red. If we're talking about the number of siblings, right? Then it makes sense for values to take numbers like 0 or 1 or 2 and so on. Right? So the variables and the values are not going to be the typical like number line that we're used to with graphing. All right, so now let's get into the difference between descriptive and inferential. All right, so descriptive statistics takes a huge amount of info, right, and compresses it so that we can make sense of it. And you are going to have sampling, right? So even though the US Census is descriptive of the entire US population, right, most descriptive statistics will take a sample population, right? So when you describe that sample population, maybe you're saying, 60% of, this sample prefers chocolate over vanilla ice cream, right? That's descriptive statistics. If you go to take that sample and now say, 60% of US residents, right, back to your bigger population, if you now say 60% of that bigger population prefers chocolate to vanilla, right, that's making an inference, right? You're taking what happened in your smaller group and applying it to that bigger population. That's what inferential statistics is. Okay, here's another example of, right, starting with that population and then going down into a sample, right, collecting data from the sample and then going back and making an inference to that larger population, right? So let's say that we collected data about some participants that started a new antidepressant drug, right? Maybe we collected information on, their sleep, how they were feeling with their mood, how irritable they were, right? All that data that we collected, and if we presented that, in a histogram or a pie chart or whatever, that's going to be our descriptive statistics, right? That's not giving our opinion at all, right? Descriptive statistics just looks at the facts, and it's hard to argue with descriptive statistics. Turning that into an inferential statistic now, we're using that descriptive information to make an inference about the larger population, right? Now we can say research suggests that 60% of people will respond positively to this drug in 2 months, right? That's not necessarily meaning that 60% of the entire world's population will have success with this drug, but it's an inference we can make based on that smaller sample size, right? We're drawing conclusions based on what we saw in the data of the smaller sample, right? We're making inferences from the sample back to that larger population, right? And it is generalizing and estimating a bit. So it's natural that there's going to be more error with inferential statistics. Okay, here's another image just so you can see, that bigger circle on the left there is that larger population. The smaller navy blue circle would be the sample population, right? So in step 1 there, producing that data, right? That's the descriptive statistics, right? Gathering that information on that smaller sample, right? Then what we're going to do is apply statistics, right? Which we'll eventually learn about probability. And we're going to end up applying some type of inference to that larger population. All right, so I'm going to leave you with this. Here are some statistics on popular social media applications. And this is going to have some descriptive statistics in here and some inferential, right? So I kind of want to challenge you to think about each one of whether it would be descriptive or inferential. Some clues for descriptive. If it says, something that happened in the past or present, it might have the word is or was or were, right? It's going to come off very factual, right? So in those Snapchat users here, right, that pie chart, that's very factual, right? They have hard data of the number of users by age of who's using Snapchat, right? But then when we get over to the left on the Instagram, right, the top right one, it says that the ad revenue is predicted to generate around 4 billion, right? So they're making a prediction about the future. So a clue that it's inferential would be having the word future or would be, could be, right? It's coming off as a prediction. Okay, so I hope this gives you a little bit of intro into the 2 different branches of statistics, and we will add more next video.